Hey, hello guys, welcome to my channel. And in this video, today we are building something production grade, end to end, a Jenkins pipeline. And in this project, if you'll add this project in your resume, this will definitely going to create an impact. So what we are building? We are building a complete automated pipeline from code checkout to deploying your application on production. Everything will be automated. We will be containerizing your application using Docker, that to multi-stage Docker builds. That means your image size from we will be taking your image size from 1 GBs to straight to MBs, and we'll be building Jenkins pipeline with security scannings, OWASP, Trivy, and image scanning. And we will be using NGINX as a reverse proxy for your applications. We will be routing your traffic from front end, back end, both. And not only that, we will be accessing your application not on HTTP but on HTTPS. Yes, we will be requesting on a secured connection. So we will be setting a TLS certificate, SSL and TLS certificate for your application. And if you guys don't have a DNS, I will show you a hack of how to create a DNS or get a DNS. So stay connected with me till the end. I will show you that a hack of how to get a DNS. So, and if you guys are new to my channel, make sure to like and subscribe because that really motivates for me to make more such content. And if you guys don't watch my previous video, that is AWS optimization tool, make sure to watch this. I have showed you how to optimize the AWS build using different AWS services. So do check that out. So without getting late, let's get started. But before getting started, I want to show you the Jenkins pipeline of how our pipeline or our flow will work like. So this is our flow. Whenever a user pushes the code to the GitHub, a webhook will be triggered to the Jenkins. And in Jenkins, these are the tasks that is going to perform fully automated. Firstly, the code checkout. And next is file system scan using SonarQube and Trivy. And code quality checks and vulnerabilities of dependencies will be shown on a SonarQube dashboard. I'll show you how to build that. And next is image build. And once the image is built, our image will be scanned using Trivy to find out any vulnerabilities are there in our images or not. And then we will push our images to the Docker app registry, and then we will deploy it directly with using Docker Compose on your server. So this is the flow, and this is the NGINX how reverse proxy is happening. So whenever the user is hitting for a request, Nginx is the middleman. Based on his request, his traffic will be routed either to the front end or back end. Like slash will be routed to front end, and API, OAuth, and WS. WS is a WebSocket because our application needs a WebSocket also. So these are the requests that will be routed to the backend. So now let me show you how our application will look. So this is our application, and look here. This is secured, means HTTPS connection is secure. Let me show you our so this is our certificate. So we are using Let's Encrypt. So build our self-signed certificate. So I will show you how to build that also. Don't worry. So now let me show you our application. This is simple full stack chat application, which I have built in one of the hackathon. Not application, but this DevOps task where I won this hackathon as a second prize, where I built the Jenkins pipeline from end to end, containerization, creating this HTTPS, everything. So this is our application, a simple chat application. And then let me show you our Jenkins pipeline, how our Jenkins pipeline will look like. So this is our Jenkins pipeline. So see here, declarative code checkout from SCM, declarative tools install, checkout file system scan for SonarQube for backend, front end, Trivy file system scan, image build, image scan, push to registry, deploy, post action after our complete pipeline. This is the end-to-end pipeline that we will be building from scratch. And this is the GitHub repository that I will paste in description section, so you guys can take a look at here. So this is my submission that I had made for this hackathon and where I won that as a second prize. You guys can take a look at here. I'm just scrolling it here, so you guys can take a look at here. So yeah, without getting late, let's get started. We'll start our setup. So you guys can fork this application from the GitHub repository. I will provide the link in description, and the complete guide for how to set up the application in local will be given in this contributing MD. You guys can take a look at over there, and there should not be any issue for you to set up it on your local. So I'll start it directly from a Docker file. So we'll start from front end Docker file. So we are using multi-stage Docker build. So first stage, so we are using Node 18 Alpine image, base image, because it is the lightweight image, and then we are creating this work directory, and then we are copying all the package.json, which installs all our dependencies required for application. So this is the command to run that npm run install. So this will install all the dependencies required for application in this stage. So this is a single stage, and this stage will cache our dependencies so that whenever we are building again, this stage will be cached from the Docker and will save our time. So in next stage, we'll build our React app. So next step, again, we are using Node 18 as a base image, and then we are creating a work directory as app, and then we are copying all the installed dependencies on our previous stage. In this stage, that is from depths here, from depths, we are copying all the dependencies here, and then we are copying all the source code. And next, we are passing this API URL at our build time. This API URL is our backend URL that will be required for our application, and then we'll build our application with this command, that is npm run build. Build will create the static files for our application. And next we will using the nginx. Nginx, so this will serve the static files. Our application will be served as a static files. So firstly we will delete all the default html files in our server, and then we'll copy the build from our previous stage into this location, because this is the location where nginx will look for the static files. And this is the nginx configuration. This is optional, you guys can give it or not, but if you guys are giving that, then you should have this nginx conf file, this file. And then finally we are exposing it on port 80 and then running our docker file. So this will be our multi-stage docker file. In a nutshell, I can say our stage one is for dependency installation, second stage for building our application, and third for serving it with the nginx. So this is the lightweight image will be formed from this docker file. So this is our backend Docker file. So our backend is based on a Java Spring Boot application. So we are using a Maven for the build environment. So we are using Maven 3.9 with JDK 17 as base image for stage one, and we are creating the Docker app directory. We are copying the pom.xml in this work directory, and we are running this command. So this will install all the dependencies required for our application and keep them handy. So that will be very much helpful. Like they will cache, docker will cache that dependencies, and whenever our rebuild process, that will avoid it. So here we are copying the source code of our application and creating the jar file of our application. This is the stage one. So in next stage, we are not directly copying the jar file in second stage, but we are making use of the Spring Boot layered feature, by which our jar file will be extracted into the layers like dependency layer, Spring Boot loader, and application layer. Means why this is very helpful means, let's say you changed your code, backend code, and not the dependencies. Then whenever the build process will happen, then dependencies layer will be cached from Docker directly, and only the application layer will be rebuilt. So that is the use of it, and this is very much eventually this will eventually speed up the build process and build our images smaller. So that is what happening over in the stage 2. So in stage 3 we are finally creating a production grade lightweight image, where we are extracting the layers that we had in our stage 1, like dependency layer, spring boot loader, snapshot, application layer, and exposing our application on port 8080. So this will create a final image, final production grade lightweight image for our backend spring boot. And now we'll look into our Docker Compose file, where how to orchestrate these different services like front end, backend, and DB in just one single command. So now let's take a look into our Compose file. So we have three different services, that is DB, backend, and front end. So in our DB service, we are using a MySQL image. Container name we are giving as chattingco./db, and the DB env files required for our DB will be in this location. That is this in our backend. That is this. This is the db.env. And next is the port, which is our on a engine which is on our MySQL is running, and the volume. So we are creating a named volume, that is DB data. So by which if even if our container gets crashed, our data will be still be persisted at this location in our server. So this is the health check that we will be doing for our DB service. So this whenever the health check will be passed, our DB service will be up and running. And then next is our backend service. So we are providing the location of our Docker file through this build attribute, and then giving the name of our image of image name, container name, and then env file. So our backend will require our env file. So this is the env file for that. This is the env file. And next depends on db, means before starting backend server service, our db service should be up and running, then only our backend service will start. And then next is front end service. Again we are providing the location of our backend file, sorry, front end docker file. And here we are passing this env variable, as I told when you in our docker file, that is this. We were passing here this react app API URL. So we are passing that at build time here, and this is the URL for on which our backend is exposed or running. And then our image and container name, and our application is exposed on port 3000. This is the host port and nginx port, and this is the named volume, that is it. And here our this is a host port, and this is the port where our application is exposed. So we are done with our Docker Compose file. Now let's test this and see whether it is running or not. So Docker Compose -d build. So for me it is cache. He has cached all my builds already, so it is will not take for me much time. If you are doing it for first time, it will take you a couple of time. So now let's test this. So see, our application is up and running. Now let's log in and see. Yes, it is up. Now let's add a user. No, I think we don't have any user here. So you can test. This is the same user. So yeah, our application is now up and running. Now in next step, we will look into our Jenkins setup. We will use a AWS EC2 instance in on which we will run our Jenkins server. So come to AWS console and we'll start from launching an EC2 instance. So go to EC2 instance and we'll launch an instance of T2 large. T2 medium will also be fine, but for not to get some stuck in a path, so I'm using the T2 large. So, and if you guys thinking that T2 large will incur my cost, then I already made a video on how to get the $200 of credits from AWS. I will provide the link in description, so you guys can take a look at it. It takes only 50 GB. Then simply launch. So now we connect our instance. This is our instance. So once you are inside your instance, first thing you need to do is update your instance. So do, and then we'll install Docker also, and then we will install Jenkins. For Jenkins, first we need to install Java because Jenkins is made on Java. So that for that reason we first need to install Java. So I'll provide all the links, required links in the description. So don't be worried. So this is the link for that where we need to install Jenkins. So come to Linux, and in here installation of Java. First we need to install the Java. So first update we have done. So copy these two commands, paste it, and hit enter. So this will install the Java first in your server, and then we'll install Jenkins. So for that, here is the command. Just take the LTS version, that is long term support. Take this complete command, and once this is complete, we'll paste that here and hit enter. So this will install your Jenkins also in your server. And now by default, our Jenkins will run on port 8080. So we need to open that port 80 of your server. So going back to your instance, and in security, you need to edit your security group. Edit inbound rules. Add a rule of 8080 because this is the port at which your Jenkins is running. Anywhere, save a rule. So we have done that now. Now take your IP of that your server and check whether it is done or not. Now as it is done, now come here, paste that on port 8080. Your Jenkins should be running. Yes, your Jenkins is now up and running. So this is the password, location of the password. Just take this, come to your terminal again, and sudo cat, paste that. So this is the password. Take this, paste here, continue. So it will ask for you to install the plugins. Select the plugins or install the suggested plugins. Now if you don't know what is it, just simply install the suggested plugins, and it will install all the required plugins for our Jenkins, and it will take a couple of minutes for your Jenkins to get up and running. Now it will ask you for to create your username and password. Just to give your username and then pin password, and keep everything as default, and give a mail also, give any item email. Let me go. Just save and continue. Okay, and this is the location URL where your Jenkins is running, and just start using Jenkins. So yes, you are inside your Jenkins now. Now we will install all the required plugins to run our Jenkins build. Before writing our Jenkins plan, we will install all those plugins first. So come to your settings, inside plugins, available plugin, and start searching for the plugins. So first we will require is JDK because our backend is based on JDK. So for that we need to install this one. So this will provide all the providers an installer for JDK tool that install Eclipse. So next is we will be requiring Maven also. So Maven integration and config file provider also, and SonarQube also because to run our dependency checks and all. For that we will be requiring a SonarQube and Blue Ocean also to make our UI look more better. And then we will be requiring a Docker also because our application is based on Docker also. And then OWASP also, OWASP dependency check, and then pipeline stage view. Here it is. Just take this and hit install. So this will install all the required plugins for your Jenkins. And again, it will take a couple of minutes here. So wait until it is done. And after it is installed, just check this box. Restart Jenkins after the installation. So your Jenkins will simply restart. And if it's taking too much of time, just simply refresh your page. So your Jenkins start. Again, give your password and username. So yes, you are inside your Jenkins. So now we have installed all the required plugins for our Jenkins. Now we'll start setting our Jenkins. So we'll start first with Trivy installation. Then we will install SonarQube server. Then we will set up OAS Docker. So let's start from first Trivy. So for that, I have these commands to install the Trivy. Don't worry, I'll provide these commands. Come to your server, paste that, hit enter. So this will install the required keys and packages for our Trivy. So wait for it to install. So yes, our Trivy is now installed in our server. And next is to install run the SonarQube server. So this is the command for that. So let's run that. Wait a minute, we don't have, I think we don't have permissions for Docker. Yes. So we are getting that error. So because we were not added Docker user. So for that, sudo user mod ag Docker and then new grp Docker. Oh, wrong command. Docker $user. Now Docker ps. Yes, it is working. Now let's take that command once again. So this will set up our SonarQube as a container, and we will connect to that container now. So yes, so now take this IP and check for port 9000. You will not be able to access that because we need to open the security group for 9000. So come to your console, security group, edit inbound rules again, and add the rule for 9000. Anywhere IP save rule. So now just refresh this. Now you will be able to access your SonarQube. Initially, admin is the user and password. And it will ask you to update your password. Give a new password. And then update. So yes, now your SonarQube also has been set up. Now we will what we'll do is we have done with our Jenkins. Sorry, we are done with our Trivy, and SonarQube also is done. Half of the SonarQube is done. Now we need to, in SonarQube we need to create a token. So for that, come to administrator, security, users, and then here token. Give any name here. Jenkins 30 day of expiry, generate token. Copy. Keep this token very much handy because it will be required. So once you copied that token, you come back to your Jenkins and you need to add that token over here. Come to settings, credentials, global, add credentials, and the secret we are adding is a secret text. Choose secret text, add that secret over here. Give ID as sonar, description, sonar token, and then create. So the token is also now created. Now token is created. Now we need to integrate our SonarQube server with our Jenkins. So for that, come back again to manage Jenkins. Come to system, and in system search for SonarQube server. Yes, here it is. And here add SonarQube server. Give the name Sonar and the URL at which your SonarQube is running. That is this. We'll just add that SonarQube server here. And then our token. The token. Why we are doing this? Because understand this process, whenever the job will hit our Jenkins pipeline, that job will be sent first to the SonarQube to perform the system scan, dependency scan. How it will send? To by this URL. To this URL, Jenkins will send that job. And once the Jenkins will complete that job, once SonarQube will complete the job, SonarQube will reply to the Jenkins saying the job has been completed. But how it will do that? For that, now you need to create a webhook. Come back to your SonarQube in the configurations, webhook, create webhook, give Jenkins webhook, and the URL of your Jenkins. Add that, and here add SonarQube webhook slash, and no secret, just create it. And now webhook is also created. And next is to install other, not install, you just save this first. Saved. And next is to install the other tools. Come to tools, not to install, like to setup, because we are also using JDK. So give the name JDK 17, install automatically, add installer, use this, and choose the version. Our application is based on Java 17 plus, so we need to choose that only. So for that, I will choose this one. And then we also need to add SonarCube installation scanner. So for that, give the name as Sonar, and everything is okay. Keep default, and I will also need to add Maven here, Maven 3, and everything keep as default, and dependency check was install automatically. Installer choose from github.com, and keep everything as is, and just save this. So yes, now you are done. You have installed your Trivy, SonarCube, who was created webhook also, and yes, this is done. So now we have set up our Jenkins completely. Now we'll start writing a pipeline. So come to here, create job, and give the name of your pipeline. Let's give chatting go CI/CD, and choose pipeline, and okay. Your description as your description, and then discard old builds. So we will keep at least two max builds, and then this is a GitHub project, and take the URL of our project, paste that here. No anything advanced, keep everything default, and pipeline script. Yes, now we'll start writing our pipeline. Now if you don't know how to write the pipeline, just simply come here and take the hello world. It will give you a simple template for the pipeline. And I have already created a pipeline code also in this project. You can take that code from here in this Jenkins file. So we will be referring from here only. So let's start our build now, pipeline. So library shared. What a library shared means, we are using here shared library concept. Means, let me show you a small thing. This is in script code checkout. We are calling the code checkout as a function. And actual thing of this code checkout, and we will passing the parameters to this. This is the function, and passing the two parameters, the URL of my application and which branch. And this is the actual that code. Here is the code checkout.groovy. Inside this function will be called. This is the concept of shared library. Means whichever the file we are giving over here in our Jenkins pipeline, that is here, that will call that function through this shared library concept. So we need to set up that also first. So let's what we'll do is just simply save this, come back to settings in systems, search for global trusted pipeline libraries. Here it is, and simply add, give the name as shared. The name whichever you will give, you need to provide that name over there. Means here, shared like this. And then which version means which what is the branch of that library. This is the main branch. So it is main, and it is the modern SCM, means from where the code needs to be pulled, that is git. And the repository for that, take this repository of this GitHub project, sorry, your repository, copy this, paste here. And no credentials, because this is the not private, public repository, and simply save. Yes, now it is saved. Now come back to your pipeline and configure. Now you will start setting it once again. So firstly, that is library shared, we'll add that over here. Now you got the meaning of what is the shared and why this dash. This is just their syntax. You need not to know much more about this. And next, agent any. What is agent any means? Agent any means, we are our Jenkins, we are not following the master slave architecture. Means Jenkins is also so called for a master slave architecture, because your Jenkins server is at one place, and you will be setting a worker node at which your complete workload will be happening. But we are not doing that. Our server and our workload is happening only in one server, that is this. So Jenkins So let me first completely explain this pipeline. So as I told you, this is what is shared now. We are using the Groovy syntax for that. And next is this tools. These are the tools that will be requiring for our build, because our backend is based on JDK. So we are importing this JDK here, and we had added this installer in our Jenkins CI setup and Maven also. And next is this environment and parameter. I will explain these two parts at the end, because you will not get when I explain now this. So let me explain that later. So next is we'll start from our stages. So first stage is clone our GitHub repository, and here steps script. This is the Groovy syntax code checkout. In this function, we are passing the two parameters, that is the application GitHub repository link and the branch where it is. These are the two links, and let me show you that also now here code checkout. You can see here git URL, and GitHub branch. So this will simply check out the code, clone the code from that location. And next up is file system scan. In this, we are running the parallel jobs. First is SonarQube backend, then SonarQube frontend, then Trivy FS, that is file system scan. Here, what we are doing is again we are here running the making use of um, Groovy syntax. This is the function for that, and passing the attributes for that. That is env.backend directory. What is this env dot now? That is what this environment comes in here. In this environment, whichever variables you declare can be used in any of the stages. In any of the stages by this env dot the variable that you declared here. See here env directory envdir is equal to backend. So envdir means that backend will be passed here. So that is what environment means. Whichever variable you write here that can be accessed in any of the stages. That is what it means. So in this we are passing the directory and chatting go backend and chatting go backend. What is this two are? Let me explain you now that. SonarQube backend, and this is the Groovy syntax. Let's go to there and see. Groovy syntax, Sonar backend, Groovy. See here. Those two are the project key and project name. You can pass any name for that. This is just the key that is required to scan your backend, and this is the code for that. This will simply scan the backend using the sonar, and in a sonar, and will check the code quality, and any vulnerabilities are there or no in your code, that all will be checked by the sonar. So that is what it is doing. This is doing for backend. The same is happening for front end also. And next is Trivy file system scan. So this will scan all the file system, like any OS dependency level vulnerabilities are there or not in your application. This will check that. And this is not the Groovy syntax. This is inbuilt function of the Trivy. And next is stage. This is stage 3. That is image build. And here again we are passing this Docker build. This is again the Groovy syntax that we are making use. And again here we are making use of the environment. This environment. Uh, Here we are passing env.registry. Env.registry is the what we are doing here. So here it is. So here we are building the image. So to build the image, what's the image name should be? First should be the username, then should be the image name, then colon tag. So that is what we are passing here. Registry is the username, and this is the image name, and this is the tag, final tag. So here final tag. Firstly, what we are taking as a tag, we are taking it as a build number. When we build our Jenkins, a Jenkins by default will provide the build number, the which build this Jenkins is running. That is what this build number tag we are taking. Let's say you don't want that, then optionally we have parameters also. You can optionally provide your own tag name also. That is what it is coming. So here def final tag. First, it is prioritizing the params. That is the tag you will provide. If you don't provide, the tag will be taken as this tag, that is build number. So that is final tag, and this is not the IP address. This is the DNS. So let me tell what is this nip.io also now only. So nip.io is one thing that whichever your IP is. If you'll append that nip.io to it lastly, that will become your DNS. See here, this, let's say this is your IP, you append nip.io, it will be mapped to this one. That is what nip.io means. And this is and this comes very much handy when you want to test it fast, or you don't have any actual DNS. That times it will come very much handy to use also. So you can make use of that, and in this project we are making use of this only. So coming back to our here, so this is the IP address, not IP address, but DNS, because we have added here nib.io and env.frontend directory, backend directory. Now let's look our backend here. Docker build. See here we are building our both images. Docker build, passing that URL, API URL, and name of the user, image tag in which location our frontend Docker file is present. Same for backend also. Next is image scan. In image scan, again we are making use of the Docker Groovy syntax. Here we are passing username, image tag, and image name and tag. So let's come there and see image, the name, Docker scan. So this is the code for that to scan the image, and the whatever the output of this will be stored in this file, that is Trivy front-end report and Trivy back-end report. The image scan report will be stored in these two files. Those files will be in your server. I'll show you that at last where the you can find these two text files. And next is pushing the repository to our Docker hub. Again we are here using Groovy syntax, and whenever we are pushing our images to the Docker hub, we first need to log in into the Docker hub. So for that we also need to go into Docker hub and take the token and add that token in our Jenkins, so that Docker login can happen. And that is what this Docker hub creds means. We will set up this next step. So here our Docker push is happening, and next is deploy. And in deploy we are passing all these environment variables, because you can see that in our compose file we were passing here in backend, we are passing the environment variable file location. But when we are working with Jenkins, we will not be providing that, because we will directly store our all environment variables in our Jenkins server only, not server, yes, server only, and this UI. And those env variables will be taken at runtime during when this deploy function will be called. And the last is post checkout, that if pipeline is succeeded, deployment will be successful, else deployment will fail. You'll get either of the message. So now we'll look into how to add this Docker Hub credentials into our Jenkins. Now we'll take the Docker Hub credentials, come to a Docker Hub, and go to the account setting, and then come to this personal access token and just create a new token and give any name here. Let me give a and give expiration date as 30, and access give as read and write, and then simply generate. So you'll get this credential token. Copy this token, go to your Jenkins UI, and over here so in here come to your setting, in go to credentials, go to global, add credential. So we need to add username and password. So what is the username? So my Docker username is this, and password, paste that token. Next give ID as Docker upgrades, and description also same you can give, and then create. So your Docker Hub credentials is also created now. And now what we'll do is we'll take that complete code from our GitHub and take it over here. That is this. And what we need to change is everything will remain same. Just we need to change is this image tag, because image sorry, this DNS name, because our DNS is now this Jenkins server. Take this IP, change it to this, may do it HTTP, and then simply save it. And we need to also add these credentials in our Jenkins. Now we'll save this simply. So now what we'll do is we'll add all those credentials in this Jenkins. So come to here. Now these are all the credentials that are required for our backend and our DB. So we'll add these all credentials in our Jenkins now one by one. So what we'll do is come to your settings, go to credentials, and in here global add credentials. Now start adding all those credentials one by one, and while adding choose the secret text because those are text. So secret is first is this, add that here, GWT secret id as this, description also do same, and then create. Do same thing for all. And one thing you remember is while adding this course allowed origins, you need to allow this one, that is http colon slash slash what's our this IP address. Take this IP, add that, and then simply add dot nip.io dot nip.io colon 3000. Why? Because this is the where our application is running front end. And then add that over here, and then create. Now we have added all the credentials in our Jenkins. So now let's set up the NGINX server on our NGINX on our server. So before that, you check if NGINX is installed in our server or not. So for that, just run the command sudo ctl. There is no NGINX installed on your server. So let's install that first. So once the NGINX is installed, move to the file called slash etc slash. So in this, you will find the two folders, that is sites available and sites enable. These are the two main files. So first move to the sites available. So in this, you need to create one file that is called as you can give any other name as you want. And in this file, you need to add this configuration. I will provide this configuration for you. So in this, you need to add this. I will explain you this. What is this? So in this, what we are saying is that whenever someone will hit this IP, sorry, domain, that is this, and this will change according to our domain. What is our domain now? Our domain is this. So our domain is this, and in this, whenever someone will hit for slash, he should be redirected to this IP. This is the where our front end is running. And same, whenever someone will hit for OAuth, that is login and sign up, he should be redirected to this. That is where our backend is running. Same for API also, for messaging and all. And next is we have this WS, that is WebSocket also. That should be redirected to backend. So these are the simple configurations. And then next, we'll save this. I think we should have opened it using a sudo. So and next, you need to create a link between sites available and sites enable. So for that, this is that command, and you can just hit enter, and then you can just verify it whether there are any syntax errors or not. So here you need to add this one bracket because it is giving error, and then simply run this once again. So the test is successful. And next is we will reload our NGINX. Yes, now it is reloaded. And next is we will change the ports of our front end and backend. And now next come to your Jenkins configurations, and then just change this IP over there. You just remove this port and simply save it. And you also need to change that in your credentials also. That is this that you have given. This one. You need to change that port also here. And copy this, and you will change that in your configurations. I will show you that. So in this credentials, you need to change that course origin. That is this. In this course origin, change password and paste that what you had copied, and just simply save. And now we'll run our Jenkins pipeline once again. Just build with parameters. So once your pipeline is completed, come to your browser and hit for that IP. And now without any port, just simply hit. You should be able to access your application. See, this is now running over your domain without any IP. It is redirecting using NGINX reverse proxy. And in next step, we will add your HTTPS. That is, so now to set up SSL, I have already provided the commands in our GitHub. You can check there. So we'll take this command and we'll come to our terminal and hit that. So this will install the certbot Python that is required for our SSL. This is a automatic certbot that will provide you a self-send certificate. And once that is installed, next is these steps we have done it already. But I think we have to restart our Nginx once again. Just hit that. This will restart our Nginx. And next is take this command and replace it with your domain name. What is your domain name? This is our domain name. So with that, we'll replace it. So this is our domain name. And then simply hit enter. So here it is asking your email. You can provide your email, any email. Let me provide a dummy email here. So provide this. So it will take a couple of minutes. See here requesting for certificate for this one. It is creating a certificate for you. So yes, your now certificate is also created. Now you can check that in your this config file. See here, certificate has been added SSL and a server also for that. And now again we will come back to our Jenkins and we'll change our ports to HTTPS. So here we were calling HTTP, now called HTTPS, and then save. So in your credentials, again change that is course origin and change it to HTTPS. That is, in this you need to provide just HTTPS and copy this, and we will add that in our credentials section. Update, change password, and then simply change that, save. So here we will run our Jenkins pipeline once again. Now once your Jenkins pipeline is successfully completed, come to your browser and hit for that IP again, domain with HTTPS, and then simply hit. You should be able to access your application and see here, this is secured now. Connection is secured. And this is the certificate for you now using Let's Encrypt. And if you are not able to access it, make sure in your security group you have opened this port 443, that is for HTTPS. This should be an issue for you if you are not accessing it. Make sure you open this, and now you are able to access it even HTTPS also. And now let's automate this completely. What we are doing now, we are manually going and triggering the Jenkins pipeline. Now what we will do is we will create a webhook from GitHub. Whenever a push made to the GitHub, that will directly trigger this Jenkins pipeline. So we'll do that in our next step. So now to create a webhook, come to your GitHub repository, go to the settings of repository, now the setting of your main GitHub account. Come to the setting, and in here you can find this webhooks. Just click it, and in this webhook I have already created a webhook. So what you do is here you have this add webhook button. You click just that, and in this payload you just give your URL of the Jenkins. That is this. Take that URL and simply add that here. And once you added that, you may do this as a application JSON and keep everything is as is and just add webhook. So this should add a webhook to your GitHub repository now. And then what you do is wait till until you get this right mark. it will take some couple of minutes of time. You just try refreshing it, you will get this mark, and then your webhook is triggered. What you do is then just simply make any changes in the code and push that change to the code. Then that will say, automatically trigger this GitHub repository, sorry, Jenkins pipeline. And that way your Jenkins code checkout and code push to complete the deployment has been automated. So this is how it is done now. If you have any doubt, drop that question in the comment. I will definitely reply to that.